In the previous video, we made a farm.dll and we compiled version 1 initially, and then we made a main class executable and compiled that against the version 1 of the farm. And then we went around and said, you know what, let's make version 2 of the farm, which essentially when we compiled it, the file name was the same. It was farm.dll, so we essentially erased the old one and replaced it with the new and improved farm. And I could say .dll, but remember, .NET does not care about the extension. It only cares about the assembly name. .NET only uses the extension when it's loading up the DLL, and at that point it's simply an assembly with the name farm. And when we executed our main class, remember this is farm version 2, when we executed main class, it said, oh, okay, I'll go off version 2 instead of version 1. And you may think, oh, that's good default behavior. If we have the latest and greatest version of the farm, then of course we want to use the latest and greatest version of the farm. But there's a couple problems with that. One, I could change my cow to a chicken. Maybe the interface for our brand new and improved version of a farm has changed. And when I say interface, I'm not talking about the C# keyword interface, but just the fact that farm version 1 had a cow, and then all of a sudden farm version 2 did not have a cow, it had a chicken. Well, and then I showed you how that if we don't have the exact types inside of assembly, then it breaks. So .NET's default behavior is not to actually use the latest and greatest version when you sign an assembly with a public key. We're going to talk about this public key. And we're not done talking about versioning, but I definitely want to talk about public keys so we can talk more about versioning. If you don't sign your assembly with a public key, all .NET cares about when trying to find your assembly is the name. It doesn't even look at the version 2. It just says, oh, I'm trying to find an assembly called farm. And sure enough, it found an assembly, a new assembly with version 2, but it doesn't care. .NET doesn't look at it. It says, oh, you're a farm assembly. I'll go off that. In general, it's good to sign your assemblies, because when you sign your assembly, you basically bind to all these items, and then .NET makes sure that we use the appropriate version. If you compile against version 1, then we'll use version 1 unless you explicitly tell me to use the latest and greatest version 2 and that sort of thing. Now, what does it mean to sign an assembly, and what are these public key things, and what is all that? Well, if you think about signing in real life, what does it mean when you sign your name to something? You probably do it every day. You go to the store, you swipe your credit card, they give you a receipt, they say please sign this, and your signature says, yes, I am authorizing you to deduct that money from my account. Or maybe you have signed a car loan or a mortgage or an apartment rental agreement or something to that effect. When you sign your name, you are putting your stamp of approval, your seal, saying, I verify this, I am legally bound. And the same is true when you sign your assembly with a public key. You are saying, this assembly came from me. Let me draw another scenario up here. If you had, the watcher, the viewer of this, say you wanted to consume my farm DLL. Maybe I wrote this really cool farm assembly, and I just compiled it and shipped it to you. Compiled it the same way I showed you in the last video. And you came around and you wrote your main class. And you said, oh, I just love printing Moo version 2 to the screen. And so you compile against my farm, and that's fine and dandy. And then all of a sudden some virus comes on your machine. You click on something and there's an executable that starts running in the background. And the executable says, I'm going to download some code from the internet. And it downloads another farm assembly. It's called farm. Its simple name is farm, and it's farm DLL, but we don't care about the DLL part because we're really worried about the assembly part. And it overwrites my farm. All right, my farm. It deletes my farm and installs itself right over my old farm. And your main class, when you run your main class, it doesn't know, it doesn't care. It just says, okay, here's a farm, has the same name as the assembly I'm looking for, and let's run cow moo. Hopefully the virus is smart enough to download code that would have a cow moo in it. And it just so turns out that, yes, this is a virus, and so instead of saying moo version 2 or moo whatever to the screen, This farm says delete all the code or delete all the files, delete everything on your hard drive. Or maybe go find their passwords and send passwords to some other offline server or something. Bad code here. In fact, I didn't even know why I'm using blue. I should be using red. Bad stuff happening in here. And so the problem in that scenario is your main class found a farm and it bound just by the name and was happy. And so you call me up and say, Jamie, your code did terrible things to me. And I said, no, my code does not do terrible things. I can guarantee you my code does not do terrible things. And all of a sudden now we got a problem. Right? What I should have done in that scenario is signed my assembly with a public key. Right? I've stamped my seal of approval. I put it on the assembly. And when that happens, when I sign my assembly, here's my old farm that got deleted. And let me use a thinner font here. Here's my old farm. Kind of funny. That got deleted. Well, when you compile against this farm, it also considers the public key. And so when you try to execute a farm and my farm goes away because this virus overwrote it, then it'll turn around and say, oh, here's a new farm, and it'll try to verify the public key, saying, oh, okay, well, yeah, you're a farm and you look like a farm, but let me check your public key and just ensure everything checks out there, that you're legit. And it'll turn out that there's no way this other company can fake my public key. It's not Jamie's public key. It's the virus's public key. If there is a public key, maybe they don't even have a public key. Maybe they did not even sign this assembly. And so .NET turns around and says, nope, not cool. This is not the assembly we're looking for. Bad news. All right? It's easy for another company to fake the name. They can also fake the version. That's easy. You just change the string right here. No big deal. And they're going to even fake the culture. To be honest, it might even help you not even worry about this culture thing. It's way down the road, and it's too bad they even put that in there. I like to think of assembly names like this, but yeah, culture's part of it. We'll look at culture later. But a company can fake the name and the version, but they cannot fake the public key. Right? Theoretically impossible. It has to do with hashing and algorithms and encryption and a whole bunch of deep dark stuff I don't understand, but I'll take by faith. So anyway, I'm going to show you in the next video how to sign an assembly and prove that this scenario is impossible. Without the proper public key, this farm will not be bound to